Hello everyone, today we are going to discuss Model Pintas 2024 Kertas Percubaan Negeri Selangor 2024 Set 2 Paper 2 Section A. Question 1. Diagram shows various types of cosmetic in the market. Okay, they give you a diagram with various types of cosmetics. Question A1, state the meaning of cosmetics. Okay, this should be written exactly what you can see in the textbook, which is cosmetics are materials or product, okay, that are used externally to cleanse, protect, and enhance one's appearance. Okay, you must have these three things, which is to cleanse, protect, and also enhance one's appearance. Okay, you must have these three in this, and material or product, okay, used externally to cleanse, protect, or enhance one's appearance. Then you get 1 mark. Okay, that's 1 mark. Question 2. State one basic ingredient in cosmetic production. Okay, basic ingredient, you can write any basic ingredient that you can find in the list. Example, the easiest one I would write is water, because all cosmetic production you have water. Okay, or you can write dyes, they put in colors like lipstick, red, pink color, blue color, green color, all that. Okay, or you can also write what else is there? You can also write moisturizer, okay, fragrance, okay. All the cosmetics, they have fragrance. Okay, you can also write preservatives, okay, because we add a preservative in there to make sure that the cosmetic lasts longer. All right, next. Question B. Table 1 shows 3 types of cosmetic, P, Q, and S, R, with its uses, okay? So P, let's look at P here, to beautify the face, okay? Q is to treat the body, and R is to provide fragrance, okay? What are the things we use to beautify our face, okay? Like we write lipsticks, okay? Lipstick can, powder, you add on powder, okay? Eyeliner, whatever that you put in, compact powder, okay, you put in to make your face look beautiful, okay. Now Q is to treat the body, so treating something, example, your body must have something wrong. Example, you have very dry skin, so you use a moisturizer. Okay, you can use moisturizer, or you don't know anything, you can just write cream. I know boys don't really know what is it with cosmetics, right? But you can write simple things that you know, okay? And lastly, R, to provide fragrance. This is not only women, men also wear, example, perfumes, okay? Perfumes. And it can also be deodorant, okay? These are also provide fragrance, okay? Question 2. Diagram shows a cooking pot made from copper. Okay, copper is an element located between group 3 to 12 in the periodic table of element. Now name this element. Okay, you can check in the periodic table given at the end of the question paper. Okay, so here's group 1, group 2, and then you have group 3 to 12 in between here. So these elements are called transition elements. Okay. Okay, others like you can find here is manganese, chromium, platinum, iron. Those are all transition elements. Okay. B, state 2 special characteristic of copper. Okay, so special characteristic here referring to the transition element. Example, they can form colored compound. Okay, like copper is blue in color, right? Or you can say they can form complex ion. Okay, and they can be used as catalysts. Okay, or one more is they can have more than one oxidation number. Okay, so these are the 4 special characteristic of transition element. You can write any 2. From here you get 2 marks. Okay. C. In the production of cooking pots, argon gas, which is inert, is used during the metal welding process. Explain why argon gas is inert. Now, why are they inert? You have 2 things to explain. Okay, why are they inert? You cannot say because they are noble gases, okay, or they are monoatomic. No, that does not explain inert. Okay, no, it is not. It is monoatomic, but if they ask you why argon is inert or why argon is monoatomic, okay, or why argon is noble gas, okay, these three has one explanation, which is the first one is they have these atoms have achieved stable atoms. Argon has achieved stable electron arrangement. Stable electron arrangement. Okay, so they do not need to, the atoms do not need to receive, okay, or donate or share electrons. Okay, these 2 points you must write. They are stable electron arrangement. They do not need to receive, donate, or share electron. This is 1 mark and this is 1 mark. To explain these 3, you need these 2 points to explain this. If they ask you, why are they inert? Why are they monoatomic gas? Or why are they called noble gases? These 3 reason is because the atom has achieved stable octet or duplet electron arrangement. They do not need to receive, donate, or share electron. Okay, you can add on here stable octet because argon is octet. Okay, but you have to be careful. Helium might be duplet. If generally, then you have to write octet or duplet. Okay. Question 3. Table shows information of atom P, Q, R, and S. Okay. A. State one subatomic particle. Okay, one subatomic particle present in the nucleus of an atom. Okay, how about the nucleus of an atom? Usually, this is the nucleus. In the nucleus, we have proton and neutron. So you can write proton or neutron. Just write one, either one. Okay, electron is outside of the nucleus, so do not write down the answer of electron. Okay, all right. Next question. B. Which atoms are isotopes? Okay, so you have to remember what are isotopes? Isotopes are atoms of the same element that has the same number of proton but different number of neutrons. So you can see here P and Q, they have the same number of proton but the number of electron is different. So you can say P and Q. Okay. All right. C. State the number of valence electron for atom S. Okay, look at atom S. Atom has 13 proton. Okay, how do we get the electrons? Proton will be the same as the number of electron. Number of proton will be the same of number of electron for an atom. Okay, so because S has how many? 13 protons. So when they have 13 proton, they will have 13 electrons. So when you arrange them in the shell, the first shell holds 2, followed by the second shell holds 8. And you have a balance of another 3, right? So 3. Okay, but this is not the answer. They want the valence. Which one is the valence? The last shell, how many electrons? 3. So their valence electron is 3. Okay. Next. Draw the electron arrangement of ion R. Okay, look at R. Where is R? R with a proton number of 12. Okay, so they are not asking atom. If it's atom, okay, the electron arrangement would be 2, 8, 2. Okay, so if it's ion, it might have donated 2 electron. Why it needs to donate 2 electron? Because if you want to achieve a stable octet electron arrangement, they need to donate the 2. It is easier to donate 2 than take up 6 electron. Okay, that's a lot of work. So it's easier to throw away 2. So when it throws away 2, it becomes 2.8. Okay, so when you want to draw, okay, you draw in the middle, make sure you have a nucleus, shaded or not. You can write the letter R inside, doesn't matter, as long as you have the nucleus. Okay, 2 in the first one, and next is you have 8 electron. Okay, 2, 4, 6, 8. And remember, because they have donated 2, Okay, so they will have charge. When I donate, I'm positive. I'm a good person. When I donate, it's a good thing, right? So how many you donate? You donate 2. So you become 2 plus. So this is R. You can label it below here. Okay. So marks will be given for correct electron arrangement and the nucleus label and correct charge. Okay. All right. Next question. 2. Natural abundance is the percentage of isotope exists in a sample of element naturally. Calculate the relative atomic mass of R in 24R, 25R, and 26R. Okay, so how to calculate the relative atomic mass is EM is we take the percentage of this 79 of 24, okay, plus 10% from the 25 plus 11% of the 26, and you divide all with 100. So you can use your calculator, you will get 24.32. That's the RAM for atom R. Okay. Question 4. Table 3 shows the electron arrangement of particle W, X, Y, and Z. Okay. Now, based on table 3, state the type of particle present in element W. So look at W here. W has electron arrangement of 2.4. Okay, so 2.4, what are they? They can be, if you want to make sure what are they actually, you can refer to the periodic table with proton number 6. So who has 6 proton number? You can see it's carbon. Okay, so you can see the type of particle here, they exist as atom. Okay, if you see this one, they exist, you see there's charge, so they exist as ion. This one also exists as ion. Okay, all right. This one might be if it's 8, 2, 4, 6, 7, 8. So because the last shell is 8, so definitely it is from group 18 and it has no charge. So this is also atom if they ask lah. Okay. All right. Next, write the electron arrangement of ion Z. Ion Z. This one, electron arrangement. You have to see ion Z. Okay, so if it's ion or atom, but you see, just write down what is written here, 2.8.8. They've actually mentioned ion, so it cannot be atom lah, as we thought it is. Okay, so it is 288 because 2 first shell, second shell 8, third shell 8. Okay, next, C, write the formula for the compound form with element X react with Y. Okay, X react with Y. Okay, you can see X here with a plus sign and Y with a -2. So when you cross, you get X to Y. Okay, so X to Y. That's the formula. Look at the charge itself. Okay, name the force that exists between the ions and the compound in force C. Okay, to know the force, you need to know whether they are ionic or covalent. Okay, so you can see that with charges, that means X has donated and Y has received. So they have electrostatic force because they are ionic bond. Electrostatic forces of attraction. Okay, electrostatic force. Okay, now question E1. Element W reacts with element Z to form a compound. Draw the electron arrangement for the compound formed. Okay, so element W reacts with the Z. Okay, W is 2 and 4. 2 and 4. Okay, then Z is 287. Okay, 287. This is W and Z is 287. Okay, so what are they going to do? Because this is non-metal with non-metal. How do I know non-metal? Because these are group 14. Okay, group 14, and this is group 17 because the valence here tells us what group they are. Okay, only group 1, group 2, and group 13. So valence electron 1, 2, and 3, they are metals. The rest are non-metals. Okay, so draw first W in the middle. Okay, 2, and then you have 4 here. 1, 2, 3, 4. So what you're going to do, you're going to overlap it with a Z. Okay, with a 2, 8, and another 7 here. So you have 1 here, you can share here, and you rub off one from the W and you put in here. Okay, so they share one pair here. So this Z is octet, but this W has not octet yet. So what do? You do another sharing with another Z. Okay, it's a long shot, but it's worth drawing it for 2 marks. Okay, do not regret drawing it. Okay, so, okay, you have one extra here and you rub off. Remember, do not add any electrons. I'm just transferring it to the side so that they can share with each other. Okay, then you can see this Z has octet. Okay, but this W has not octet. So you have to keep on sharing until they achieve octet. Okay, 2, 8. It doesn't matter. You don't have to draw it like very, the circle must be very circly or what. All you have to do is, as long as you can see the shell. Okay, so rub one off and put one here. Okay, and the last one here, because it's still not octet. 2, 4, 6, so you need one more here. 2, 2, 4, 6, 8, and 2, 4, 6, and one more here. Okay, so this Z, and this is the W. Okay, so with this you will get 2 marks. Okay, question 2, state one physical property of the compound formed in 4-1. So this is actually a covalent compound, right? Because they share electron. So you can write they have low melting point, boiling point, very easy. Low melting and boiling point. They are insoluble in water. Okay, you can also write they do not conduct electricity at all states. Okay, they are soluble in organic solvent. Okay, any one will be accepted. Okay, question 5. Diagram shows a medal made from bronze based on diagram 3.1. What is the meaning of alloy? Okay, so we need to know what is the meaning of alloy. Okay, alloy is a mixture of 2 or more elements. Mixture of 2 or or more element. Okay, it's a mixture. Okay, where the main element is metal. The main element is metal. Okay, all right, now state the main metal present in bronze. Okay, bronze and brass, they have the same main metal, which is copper. Okay, you can write copper, you can write the formula because they say state. If they say name, then you have to write down the name. Okay, but this one, either one is accepted. Question 3. Compare the hardness between the main metal stated in 5A1 and bronze. That means compare the hardness between copper and bronze. So you must mention who is more harder. So first mark is bronze is harder than copper. Okay, there you go, 1 mark. Okay, there's the answer here. Okay, so this is 1 mark. Bronze is harder than the main metal, which is the copper. Okay, then the second mark is the arrangement of atoms in bronze. The arrangement of atom in bronze is of different shape and size. Okay, so because of that, the layers of the atom cannot slide easily when force is applied. Okay, do not say it will not slide easily. Not to say it cannot slide at all. It can, but very difficult. Okay, so cannot slide easily. You didn't say do not slide. Okay, it cannot slide easily. That means it is possible with very, very high force. So you can say the layers of the atoms in bronze cannot slide easily when force is applied. So this is your second mark, and this is your third mark. You get 3 marks. Okay. Question B. Diagram 3.2 shows a chandelier. 1. Name the suitable type of glass to make this chandelier. Okay, so this is a very beautiful glass which has high refractive index. So we use them lead glass. Okay, you can see sometimes they make doors, beautiful doors, windows, same type of glass. Okay, name 2 properties of the glass. Okay, so you can say high refractive index. Okay, high refractive index, you can say high density, okay, because of these fractures, they have color and they can form very beautiful glass. Water is also produced in this reaction. So you know this is a reaction between alcohol and carboxylic acid, which actually produced water. So they are asking you to write down the chemical equation for the reaction. So just take what is given here, which is C3H7OH. Add on C3H7COOH. Okay, so what will you get here? Okay, you need to uh, write down the carboxylic first. Take this part here, Okay, so I'm going to take C3H7COO. Okay, because this one, we're going to remove this and this to be water, because you see water is also produced in this reaction. Then we take this behind part, the front part of the alcohol, okay, and put it here, C3H7 plus H2O. Okay, so that's how we write down. Okay, so it's automatically balanced. Part of the ester. Okay, now state qualitative information and quantitative information that can be obtained from the chemical equation. So for this, okay, you have 3 marks here. You can mention who are the reactants. The reactants are propanol and butanoic acid. The second one is the products. Okay, the products are propyl, butanoate, and water. Okay, and for the quantitative, okay, this is the quantitative information. 1 mole of propanol reacts with 1 mole of butanoic acid to produce 1 mole of propyl butanoate and also 1 mole of water. That is the quantitative part. Okay, the first part you wrote here is the qualitative part. Okay, so 1, 2, and 3 marks. Okay, it's quite easy. Question C. Amani used 60 gram of pure propanol to be reacted with butanoic acid to make fluid Ferrari. Calculate the mass of the glacial butanoic acid that needs to be used. Okay, so this is a stoichiometric problem. So first thing is you find the number of mole of propanol, C3H7OH, okay, which is mass divided with the um, molar mass for propanol. You have to calculate 3 times 12 plus 7 plus 7 times 1 plus 16 plus 1 again here. So that is equivalent to 60 divided with 60. Okay, so you get 1 here. Okay, now next is you have to compare. Okay, from equation, okay, 1 mole of C3H7OH, you use 1 mole of C3H7COOH. If this is something else, then it has to be here as well. Okay, so lastly, we need to find the mass of C3H7COOH, which is we take the 1 mole, we times with um, the molar mass of 3 times 12 plus 7 times 1 plus 12 plus 16 times 2 plus 1. Okay, so that is equivalent to 88. So 1 times 88, it is 88 gram. Okay, so 1 mark here, okay, to find the number of mole, 1 mark here. and 2 marks here actually, and 1 mark here. So total 4 marks. Okay, most of the time they give you 3 marks here. Sometimes they are very generously. They want you to write this ratio here to get 2 marks. So just write as they want to, right? Question 7. Diagram 5.1 shows apparatus set up in an experiment to investigate the effect of two different metals on the rusting of iron. Okay, so they give you here iron nail and magnesium, and iron nail and silver here. Okay, so now rusting is a redox reaction. State the type of reaction that occur on iron metal when iron metal rusts. Okay, so when iron metal rusts, what happened? It oxidizes. So it is oxidation, because iron becomes iron 3. Okay, from iron becomes iron 2 plus and becomes iron 3 plus. That is the rust. Okay, now from your answer, in which test tube does rusting occur? Okay, so you can see here actually test tube B. Why? Because this one is a more electropositive metal. So this one is the one that will oxidize first. But here, because iron is more electropositive, so iron will undergo oxidation first. Okay, explain your answer. So to explain your answer, you need to write down that silver is less electropositive. Okay, silver is less electropositive than iron. Okay, so iron will undergo oxidation and rust. Okay. Question B1, write the half equation for the rusting of iron. Okay, so you start with Fe becomes Fe 2 plus by releasing electron. Okay, do not go until 3 plus yet because it starts off with this. Okay, now state one observation in the color of the mixture when iron is rusted. You can see blue spots present. Okay, because remember, you look at this diagram here, they add on potassium hexacyanoferrate. Okay, potassium hexacyanoferrate will detect the presence of Fe2 plus. When there is Fe2 plus, you can see the blue spot. Okay. Next, state the purpose of using potassium hexacyanoferrate. Well, I actually explained it to detect the presence of Fe2 plus ion. Okay. All right. C. In test tube A, what happened to the color of the mixture? Okay, so here there is no iron 2 plus, so you can't see the blue, but you can spot pink spot present. Okay, because of the phenolphthalein that is added that detects the presence of hydroxide ion. Okay, now they ask you name the reaction that occurred to magnesium. So as I said just now, let's look at magnesium here. Magnesium is the one that will undergo oxidation. So here, oxidation. Okay. All right. D. Diagram shows a rusted basketball pole in school. You are assigned to restore the condition of the rusted basketball pole. State your action. It's only 2 marks. So what do we do? Okay, you can do many things. Okay, you can choose which one is a better one. Okay, so you can coat it with plastic. Okay, you can coat it with plastic. Coat it with plastic. Okay, why? Because you can say plastic can prevent corrosion. Okay, it's a protective layer. It can prevent the exposure to the iron with water and oxygen. Or you can say it's low cost. Okay, you don't need to buy a new one. Okay, all right, low cost. You can prevent water and oxygen, which helps for the rusting of the iron to occur. Okay, any one is accepted. Okay. You can plastic also can prevent corrosion faster. Okay, it forms a protective layer. Anything from here, you will get your mark. Okay. Question 8. Diagram shows the structural formula of two organic compounds A and B. Okay, so from the compound here, you can see this is an alkene because there is a double bond here. see. And here you can see OH, so this is an alcohol. Okay, so question A1. What is the functional group of compound A? So you've already seen here, okay, because it is an alkene, the functional group is double covalent bond between carbon atoms. Okay, C double bond C. Okay, now name compound B according to IUPAC nomenclature here. So look at this. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4. So according to IUPAC, how do we write them? Butan dash 2 all. Okay, if it is carbon number 1, butan 1 all, or butanol is accepted. Okay, B. Describe a chemical test to differentiate the two compounds. State the observation involved. Okay, so you can use, because this is an alkene and an alcohol, you can use bromine water. Okay, because you know compound A will decolorize the brown bromine water, while alcohol will not. While compound B will not decolorize. That means the color remains the same lah. Okay, or you can say the color does not show any changes. Okay. C. Through a suitable reaction, compound A could be compounded compound B. So alkene, you want to change to alcohol. Okay, so how do you change to alcohol? Is through hydration. Okay, through hydration. Okay, question C2. State the catalyst and the optimum condition. So for hydration, you need to use phosphoric acid, H3PO4. Okay, phosphoric acid, or the optimum temperature would be temperature 300 degrees Celsius and pressure of 60 atm. Okay, this is the condition for hydration to occur. Okay, right. D. Synthetic rubber is an artificial elastomer. Diagram 6.2 shows synthetic rubber. Suddenly you see it's like a polymer, right? Sometimes carbon compound can relate with polymer because polymer, part of it are petroleum compounds, so they are actually hydrocarbons. Okay, so they are synthetic rubber that is used to make cooking utensils such as silicone spatula to avoid pot from scratching. Okay, why is silicone spatula more suitable to be used compared to plastic? Why did they just use plastic? Okay, because plastic actually are not chemically inert. This silicone, they are chemically inert. So if you use plastic spoon, they'll start to melt and probably react with the food that you are cooking. Okay, you can also say they are resistant to high temperature. Also can. Question 2. Synthetic rubber is widely used as large amount is produced every year. Unsustainable use of synthetic rubber will cause negative effect to the environment. State and explain the effect. Okay, so very easy. This is like very logical question. State and explain. So what is this? What is that? You can say it lead to environmental pollution. Okay, you can just write pollution. Because why? Synthetic rubber takes a long time to decompose. This is very simple, very basic science questions that a lot of students are able to answer. All you need to do is just write down pollution because it takes a longer time to decompose. It will not decompose in a very short period. Okay, all that is accepted. Section B, question 9. A. State the meaning of heat of combustion. So this is an essay question of thermochemistry. Okay, so 1 mark for meaning. You have to write down heat of combustion is the heat released when 1 mole of substance is completely burned in excess oxygen. Okay, question B. Butane and butanol can burn in excess oxygen gas to produce carbon dioxide and water. Write the chemical equation for both reactions. So we know that butane, okay, when they burn in excess oxygen, so butane plus oxygen, you get CO2 and H2O. Now to balance this, you see here 4, you add on 4 here. Next is you balance the hydrogen. Hydrogen got 10 here, so you put 5 here, so 5 times 2, you get 10. Now, lastly, you balance the oxygen. So oxygen here, 4 times 2, you have 8 here, plus 5 here. So you have 13 here. Okay, so you can't put here, if you put 12, you put 6, it becomes 12. You put 7, it becomes 14. So you can't do that. So what do? You put 13 over 2. Okay, this is accepted. You can use fraction, or you can just times everything with 2, also accepted. Okay, now butanol, C4H9OH. Same thing, 4 here, put a 4 here, and then 9 plus 1, 10 here. Okay, there's 10 hydrogen. So put a 5 here, 5 times 2, 10. Then finally, you can see 4 times 2, 8 here. 8 plus 5 here, you have 13 here. Okay, sorry, 13 here. Okay, so here you put 12 because you have 1 oxygen here. So plus 1 here, 13. So this is balance. Okay. Okay. Question C. Table shows the heat of combustion for two compounds, methane and propane. What is the meaning of fuel value? Okay, fuel value you have to write down is the amount of energy, heat energy released when 1 gram of fuel is completely burned in excess oxygen. Okay, it goes by gram. Okay, now 2. Justify which compound is a better fuel. Explain your answer. So you want to choose which one. Okay, so you have to see because of the reason in terms of the fuel value. Okay, so calculate the fuel value. The fuel value for methane, you take 890 here, divide with 16. Okay, and propane 2220, divide by 44, you get this. So make sure you write down until 1 or 2 decimal places. Okay, so from this you can see methane has a higher fuel value. So you choose methane because heat is produced higher when 1 mole of substance is burned. For methane, when you burn 1 mole, you get 55. But for propane, when you burn 1 mole, you only get 50. So the fuel value for methane is higher. Okay? Question D. Diagram shows a reaction between zinc powder and copper sulfate solution. Okay, so they put in initial temperature, you can see 27, and highest temperature is 38. So you know it's an exothermic reaction because temperature increase. Okay, now they're asking you state the temperature change and the type of reaction. Okay, so the temperature change is 38.5 minus 27. Take the final temperature minus the initial, you get 11.5. So this is 1 mark. Okay, reject without unit. Make sure you have unit because temperature is degrees Celsius. So as I said just now, you can see that the temperature is actually increasing. So this is exothermic reaction. Okay, do not write the heat of precipitation, the heat of whatever. Type of reaction is either endo or exo. Okay, now next is to calculate the heat of reaction. How do we calculate heat of reaction? We use two formula. Okay, so first is you find mc theta. Q is equals to mc theta, which is the heat release. So 100 times 4.2 times 11.5. Where is this 100? Is the volume of the copper sulfate solution. Okay, and you have 4830 joule. Next is you find the number of mole, MV over 1000. This is the concentration of copper sulfate, and the volume you get 0.05. Okay, this is 1 mark, this is 1 mark. Then finally, delta H is equals to Q over N. So 4830 divide with 0.05, you get this. So final answer must have negative symbol, okay, and the unit kilojoule per mole. Okay. Then next question is write the thermochemical equation and you have to draw the energy level diagram. Okay, the thermochemical equation, just like any equation, but the difference is now you need to write the delta H here. Okay, so that is 2 marks. Okay, Zn plus Cu SO4, you get Cu plus Zn SO4. Okay, and the energy level diagram, because this is an exothermic reaction, so it goes down. Make sure you have the equation here and also the delta H label. With all this, they will give you 2 marks. Okay. Question 10. Diagram 8 shows experiment to study the decomposition of hydrogen peroxide H2O2. 1 spatula of powder X is added into the hydrogen peroxide solution. Powder X is used to increase the rate of decomposition of hydrogen peroxide. Okay, so that's the hint for you here, where powder X is a catalyst which will increase the rate of decomposition. Now, A1, based on experiment, what is the definition of rate of reaction? Okay, so rate of reaction, the volume of oxygen gas released per unit time. Why oxygen gas? Because this reaction, decomposition of hydrogen peroxide, releases oxygen gas. So write down in the meaning here. Okay. Next, identify powder X and state its function. So you must know what is the catalyst used for decomposition of hydrogen peroxide, which is manganese 4 oxide. Okay, you have to write down its function as well. What is the function? It is as catalyst. Okay, or you can say increase the rate of reaction. If you want to say faster, you use faster the reaction. But when you want to use rate, you must say increase. Okay. Next is write the chemical equation for the reaction of the decomposition of hydrogen peroxide. H2O2, you will get oxygen and water. Okay, and then you balance with the 2 in front here and here. So this is 2 marks. Okay. Question B. Table shows 3 experiments that are carried out to investigate the factors affecting rate of reaction. Okay, so you have 3 sets here with different condition. Okay, so let's look at what is the difference between set 1 and set 2. There's hydrochloric acid here and there's sulfuric acid here. And for set 3, you have a higher temperature. Okay, so based on this information, compare the rate of reaction between set 1 and set 2. Okay, so you know set 1 and set 2. One is using a both are strong acid, but this is monoprotic acid and this is a diprotic acid. So you have double the concentration of hydrogen ion. Okay, so when you want to explain, you have to explain using collision theory. Okay, so let's see for set 1 and set 2. First, you mention whose rate is higher. Of course, the set 2 is higher than set 1. Each sentence, you must compare it with set 2. So in set 2, monoprotic acid is used, while set 2, diprotic acid is used. So the number of hydrogen ion per unit volume is higher in set 2 than set 1. Okay, and the frequency of collision between who? Between the zinc. Okay, because it's H2SO4 or HCl against zinc. Okay, so there's hydrogen and zinc atom is higher in set 2 than set 1. And finally, the frequency of effective collision between the particles in set 2 is higher than set 1. Okay, and you can see between set 2 and 3 here, the difference is the temperature. Okay, so for temperature, mention also the same thing. Which one is higher? Set 2, set 3 is higher than set 2. Okay, then the temperature is higher for set 3 than set 2. Okay, this is second mark. Why? Because the kinetic energy, when temperature, we talk about the kinetic energy of particles in set 3 is higher than set 2. Okay, don't just say the kinetic energy set 2, set 3 is higher. No, the kinetic energy of the particles. Okay, then the last two is the same. The frequency of collision between hydrogen ion and zinc atom is higher in set 3, and the frequency of effective collision between particles is higher in set 3 than set 1. Okay, so these type of questions are very simple to get scored 10 marks just by explaining the difference in the rate of reaction. Okay, question C. Write a balanced chemical equation for the reaction between hydrochloric acid and excess zinc. Then they want you to calculate the maximum volume of the hydrogen gas. Okay, so for this, so first write down the equation, Zn plus HCl, you get ZnCl2 and H2. So balance it by putting a 2 here. Okay, this is 2 marks. Next is to find the mole of HCl, which is 50 times 0.1.0 divided by 1000, you get 0.05. Okay, so you use 2 mole of HCl, you get 1 mole of hydrogen gas. Okay, so here you use 0.05, so here you use 0.025. Okay, so from here 0.025 times 24, because they want gas, right? 0.6 dm cube. Make sure answer in dm cube. Do not need to change to cm cube because they don't ask you to. Okay. Section C, question 11. Diagram shows 2 beakers filled with ethanoic acid and containing calcium carbonate. Okay, so you can see here there's bubbles and here there's no bubble. Okay, now you have distilled water here on your left and benzene on your right. Now, based on diagram 9.1, explain the differences in the observation between these 2 beakers. Okay, so to explain this, okay, you can draw a table to explain beaker X and beaker Y. Okay, so you can tell here that ethanoic acid ionized in water, but here it does not ionize, or you can say it remain as molecule. Okay, so the next point they will give you is because you mentioned about hydrogen ion is present. Here, no hydrogen ion. Okay, and you can say reaction occurs. Okay, or carbon dioxide gas is released. Do not say gas bubble release, because we already know gas bubble release. What is that gas bubble? Carbon dioxide. Or you can say no reaction or no carbon dioxide release. Okay, that is explaining. If you mention about uh, gas bubble, that means that's not explaining. Gas bubble is there. That is the observation. But what's the reason? Okay, and yes, you can write your answers in table. Question B. Diagram shows two solutions, sulfuric acid and sodium hydroxide. Now, sulfuric acid was completely poured into the beaker. Using stoichiometric approach, determine which solution is in excess. Okay, then explain one way to verify the presence of excess solution. Okay, so write down the equation first, okay, which is H2SO4 plus NaOH, you get Na2SO4 and water. Okay, then first you find the mole of sulfuric acid, 0.001. Okay, the next is you find the mole of sodium hydroxide. Okay, mv over 1000. Use the formula mv over 1000. Okay, this one also same. Use the formula mv over 1000. Now you compare. Okay, 0.002 mole of sulfuric acid react with 0.004 mole of sodium hydroxide. Okay, so from here you can see that actually here from here you can see that sodium hydroxide is in excess. Okay, sodium hydroxide is in excess because you have more of this than this. Okay, so what can you do? You have to see, you can use a litmus paper. Okay, so since this is sodium hydroxide, so you can use a red litmus paper, turn blue. Okay, indicating that the mixture is alkaline. Okay, so see who is in excess. You try. If you have more number of mole of sodium sulfuric acid, then you use a blue litmus paper. The blue turns red, then you know it is acidic. Okay, all right. Question C. A pupil wants to prepare a standard solution for the purpose of titration. 1. State the meaning of standard solution. Okay, so standard solution is a solution with a known concentration. That's it, known concentration. Okay, next is you are required to prepare a standard solution 100 cm cube of 0.1 mole per dm cube hydrochloric acid from 2 mole per dm cube stock solution. So the pekat one, the concentrated one is 2. You want to dilute it to become 0.1. So use the formula M1 V1 is equal to M2 V2. So 2 is before. Okay, this is what we're looking for, V. M2 is we want to make it into 0.1 with a volume of 100. So you get volume 5 cm cube. Okay, make sure you have 5 cm cube. All right, now finally, describe the steps to prepare the standard solution. Okay, so you need 5 marks. So you have 5 steps. Okay, you can put into 5 steps, but you have these points. First, you need to measure 5 cm cube of hydrochloric acid. Okay, then you use a dropper. You add the distilled water until it reaches the calibration mark. Finally, you can close and invert and shake to obtain a homogeneous solution. Okay, you must mention homogeneous solution because that's how stock solution is done. Okay.